You press a button on your TV remote and the channel just changes. You don't even think about it, right? But have you ever stopped to wonder what's actually happening in that split second? Well, that's exactly what we're going to dive into today. Seriously, think about it. How does pressing volume up translate into the sound actually getting louder? Or how does a quick zap from a barcode scanner at the supermarket instantly pull up the price of, your favorite biscuits? It feels like magic, doesn't it? But it's all down to some really, really clever engineering.
And the secret, the little hero of our story today, is this tiny but incredibly powerful component working silently behind the scenes. It's an invisible translator, converting one language into another at literally lightning speed. And this little translator has a name. It's called a decoder.
Shallow. Let's get into it. What exactly is this little digital brain that's running so much of our world? It's time to properly meet the decoder.
Okay, so here's the deal. A decoder is what's called a combinational logic circuit. That's just a fancy way of saying its output depends only on the inputs it has right now. At its core, it takes a compact coded input, usually binary, the ones and zeros that computers speak, and it turns it into a very specific separate output. And here's the magic rule. If you give it n input lines, it can control up to 2 to the power of n unique output lines. It's a fundamental building block of, everything digital. Now, take a look at this diagram. This visualizes that rule perfectly. What we're looking at is a 3 to 8 line decoder. You can see the 3 input lines on the left, X, Y, and Z. Now, depending on the combination of signals on these 3 lines, on or off, 1 or 0, exactly one of the 8 output lines on the right, from D0 to D7, is going to get activated. It's kind of like having 3 light switches that can control 8 different lights, but only one of those lights can be on at any given time. This is the whole idea behind a decoder. One specific input code, one specific output action.
Okay, so that's the theory. But how does this jump from an abstract circuit diagram to something we can actually see and use every single day? Let's check out how a decoder takes a simple code and turns it into a real, visible action. Just think about the numbers on your digital alarm clock, or maybe your microwave, or even a calculator. Each one of those digits is made up of 7 little LED bars, or segments, right? Well, a decoder is the little genius that figures out which of those 7 bars to light up to create the number you need to see. And for this, a very special type of decoder comes into play, the BCD to 7-segment decoder. Now, BCD just stands for binary coded decimal. It takes a 4-bit binary code, which is just enough to represent all the numbers from 0 to 9, and its whole job is to send out the right signals to those 7 segments, usually labeled A through G, to display that number. So if the binary code for the number 2 goes in, the decoder sends out the signals to light up just the right segments to make a 2 appear. Simple as that.
Let's look at a truth table to make this crystal clear. Now, this table shows every possible input and what output it creates. For instance, if the binary input on our lines X, Y, and Z is 0, 1, 0, you can follow the line across and see that only one output, D2, becomes active. It gets a 1. All the others stay at 0. सीधी बात है, one code, one specific action.
All right, let's zoom out a bit from just simple displays and go deep inside the heart of our computers. Because in there, decoders are playing an even more critical role, managing huge amounts of information at incredible speeds. Your computer's memory, the RAM, is organized into millions, sometimes billions of tiny addresses. When your computer's brain, the processor, needs to grab or save some data, it has to find the exact right address. A decoder acts like a super fast, super efficient switchboard operator. It takes the address from the processor in binary code and boom, it activates the one specific memory chip or location that corresponds to that address.
And this is where it gets really cool, because decoders have a hidden talent, a secret identity, if you will. By adding just one more input pin, something called an enable input, the decoder gets a whole new ability. It transforms from just a simple code translator into a data router.
And this image shows that superpower perfectly. Look at that E or enable pin. Just think of it as a master on-off switch. When it's disabled, nothing happens at all. All the outputs are off. But when you flip that switch and enable it, the decoder springs to life. Now the main data signal comes in through this enable pin. And the other inputs, A and B, don't just select an output. They decide which path that main data signal gets sent down.
And this new function has its own name. It's called a demultiplexer, or just demux for short.
Its entire job is to take one single stream of data and distribute it to one of several possible destinations. The address inputs tell it where to send the data. This is absolutely crucial for communication systems and for routing all the information flying around inside a computer. Now, if we're going to talk about decoding, it's only fair that we also talk about its opposite number. To really get what a decoder does, it helps to look at its inverse, the encoder.
This table lays it out perfectly. They are basically two sides of the same coin. An encoder does the exact opposite job. Think about your keyboard. When you press a single key, an encoder takes that one active signal and turns it into a binary code that the computer can understand. So, where a decoder goes from n inputs to 2 to the n outputs, an encoder does the reverse. It goes from 2 to the n inputs down to just n outputs. So, an encoder compresses information and a decoder expands it back out again.
So, we've seen what they are, we've seen how they work, but let's bring it all home. Why should you care about this tiny, invisible little component? Well, to put it simply, our modern world just would not work without them. I mean it. They are the unsung heroes in pretty much everything. The remote in your hand, the barcode scanner at the store, the digital clock on your wall, the calculator on your desk. They're deep inside your computer, selecting memory, routing data. They're in security systems. They run traffic lights. And they're even in musical instruments, helping to create sounds. They are truly and very silently everywhere.
So, the next time you press a button, or you scan an item, or you just glance at a digital clock, maybe take a half-second to think about that incredible journey of translation that's happening in an instant. It really leaves you wondering, doesn't it? What other hidden components, what other invisible translators are working all around us right now, making our digital lives possible?